In this lesson, we will be explaining the reactivity of alkali metals. So we will be answering the question, why are the alkali metals so reactive? The elements in group number 1 of the periodic table, which are the alkali metals, are lithium, Li, sodium, Na, potassium, K, rubidium, Rb, and cesium, Cs. They are all very reactive metals. So let's look at the electronic structures of the first 3 alkali metals. There's lithium. It has 3 protons and 3 electrons occupying 2 energy levels. It has 1 valence electron, which is 1 electron in the outermost shell. This is the electronic structure of sodium, Na. It has 11 protons and 11 electrons. 2 electrons in the first energy level, 8 electrons in the second energy level, and 1 valence electron in the third energy level, which is the outermost energy level. Potassium is the third alkali metal. It has 19 protons in the nucleus and 19 electrons occupying 4 energy levels. 2 electrons in the first energy level, 8 in the second, 8 in the third, and 1 electron in the outermost energy level. So how many electrons are in the highest energy level of all the group 1 metals? 2, 1, or 8? Correct, that is 1. Elements belonging to group number 1 in the periodic table, which are the alkali metals, all have 1 valence electron, which is 1 electron in the outermost shell. The electron in the highest energy level is lost when an alkali metal reacts. These metals have to lose just 1 electron in order to achieve a full outer shell, and as a consequence, chemical stability. Therefore, it's relatively easy for them to transfer their outer electron for other atoms. After all, it's only 1 electron that they have to lose. So what's the charge on the ion formed when an atom of an alkali metal reacts? Is it 1 minus, 1 plus, 2 minus, or 2 plus? Excellent, that's 1 plus. So we have Li plus, which is the lithium ion, Na plus, which is the sodium ion, K plus, which is the potassium ion, and so on. This is because they lose 1 electron only. Losing 1 electron meaning loss of negative charge. There's a trend in alkali metals. They go more reactive as we go down the group number 1. This means that potassium, for example, is more reactive than sodium because it's below sodium in group number 1. This actually means that the outer electron in potassium is lost more easily than the outer electron in sodium or even lithium. The rationale behind this is that if an electron is further from the attractive force of the nucleus, it's easier to remove it from the atom. And as you saw in potassium, the valence electron is in the 4th energy level. However, in sodium, it's in the 3rd. In lithium, it's in the 2nd energy level. So being in the 2nd and the 3rd energy level makes it closer to the attractive force of the nucleus compared to being in the 4th energy level when it comes to potassium. Any electrons in the highest energy level of an atom are also shielded from the nucleus by the complete lower energy levels, which are full inner shells of electrons. So basically, it is harder for lithium to lose its outer electron because it's near to the attractive force of the nucleus compared to other alkali metals. Remember that lithium is on top of the group on the periodic table. When it loses its electron, which is its outer electron, it forms an Li ion, a lithium ion with a positive charge, Li+. Now let's take a look at potassium. It is easier for potassium, which is K atom, to lose its outer electron because it's further away from the attractive force of the nucleus, and it's shielded from the nucleus by more inner shells of electrons compared to lithium. When potassium loses its outer electron, it forms a potassium ion with a plus charge, so it's K plus ion. The conclusion from this lesson is that alkali metals are very reactive, and this reactivity increases as we go down the group because it becomes easier for the atoms to lose their one electron, because the outer electron would be shielded by more energy levels when we go down the group.